Live on TT.
Well, I thought I hit stop streaming by accident on YouTube, I thought.
No, I just have somebody over there going, and then he goes like this.
All right.
All right, guys, welcome. Welcome, welcome. I know it's been a while, but I am so glad to be back. It is fully summer break now, so let's do some math. So this is one that I've been seeing a lot lately. So let's get into it. What do you think the answer is? Let's get into it. So this is getting into, order of operations, right? Order of operations is key. And this problem really helps to show why the order of operations is important, right? Why PEMDAS is important, why GEMMA, however you learn it, that we all go through the same order of operations and do this problem in the same way, so we all get the same answer. So ultimately, what I'm going to keep saying is that this problem in particular is just a really poorly written problem. It's just not a well-written problem. Okay, but let's take a look at this. So the reason why there's so much debate around this is because I think a lot of people learn the order of operations is PEMDAS. Please excuse my dear Aunt Sally. Okay, now most people, at least in the United States, most people in the United States will learn PEMDAS or they'll learn GEMMA or something like that. I don't know if any of you are from another place or grew up another place that you learned something different. Put it in the chat because I want to know what other different things there are. So the order of operations, again, so we've got, please excuse my dear Aunt Sally, we've got parentheses, exponents, multiplication, division, addition, and subtraction. Okay, now if we go left to right like this, please excuse my dear Aunt Sally, we would get 1. Okay, however, 1 is not actually the correct answer. And the reason for that is because if you are only shown that it's PEMDAS, and PEMDAS is like the be all and end all, okay, you might think that you have to do multiply, then divide, and then add, then subtract. But actually, that's not how it works. So the way that the order of operations actually works is you would do multiply or divide left to right, whatever comes first. And same thing with add and subtract. You would do add or subtract left to right, just like reading order, okay? So in this case, in this one right here, I would do, of course, I don't think anybody is going to debate the very first step that we do, which is we're gonna add the 2 plus the 1. So once we add the 2 plus 1, we get 3, and then I can actually drop the parentheses, okay? Well, I can say I can drop the parentheses, or I can leave them. Sure, it doesn't really make a difference because ultimately, like what I've done is I've taken care of what's in the parentheses, right? I've done 2 plus 1, which is 3. Now, since there's nothing else that needs to go on in those parentheses, I can drop them. I can get rid of them. But the thing is that this 2 outside the parentheses is the same thing as 2 times 3. Now I'm just going to use the little dot for times. I'm not going to use the X mark because, we'll use variables and stuff and that can get really confusing. So now all I'm left with is multiplying and dividing. That 3 looks really tiny without the parentheses around it. So now, if I were going, no sound. Okay, let's see. All right, no sound. Let's see.
It's definitely going out. So it might be a TikTok thing. Can I get your
Oh, interesting. Yeah. All right, hold on. Mr. Mathed Up is here. Oh, can't say anything because nobody can hear me.
But I just checked the same feed going directly to
device not connected.
right, but the one on top is.
Can we hear it now?
It was muted for some reason.
Oh, that's weird. It was muted. Don't know why. Yay, it works. Okay, good. So let's rewind. But since I wrote down such lovely notes. So basically, what's going on is when you have this order of operations, we're going through PEMDAS, okay? So what we can do is, again, multiply and divide, we're gonna go left to right. Add and subtract, we're gonna go left to right. It doesn't matter which one comes, well, you don't have to do multiplication first if it's not first left to right. So I saw somebody on there asking like, why wouldn't you distribute? And the reason I wouldn't distribute, well, so here I'll get into why you don't distribute, but the main reason is because this is not just a 2 times 2 plus 1. This is a 6 divided by 2 times 2 plus 1. Okay. So here I'm going to take care of my parentheses first, and I've got, so that gives me the 3. So now I've got 6 divided by 2 times 3. So if I were thinking like, okay, now I have to do the multiplication, right? Now I would have 2 times 3, which is 6. And then I would do division. 6 divided by 6 would give me 1. However, what we do instead is, because we go multiply or divide left to right. So what we actually do first is we do 6 divided by 2, which is 3. And then that 3 here is here, right? So then 3 times 3 gives me 9. Now, going way back to the beginning, and I said this, but you guys couldn't hear me, but that's okay. This is a poorly written problem. Like, this is not a good problem. So the way that you would write this, if you wanted this to actually equal 1, we would need to play around this, right? We would need to play around with this a little bit. Or if you wanted to make sure that it definitely equaled 9, that nobody would be confused as to why it equals 9 versus 1 or 1 versus 9, you would need to write this a little bit better. So again, so the 6 divided by 2, so the reason why we wouldn't distribute is because this is not just a 2. This is a 2, but it's being attached to this 6 through a division symbol. So what this is actually is 6 divided by 2, which is the same thing as 6 over 2, which is 3. So then you have 3 times, you could distribute the 3 there, sure, right? After you do the 6 over 2, you could distribute that 3 and that would work. But you would still ultimately, the correct answer for this is going to be 9. But again, this is a badly written problem. That's why they go viral. That's the whole thing, is that they're going viral because everybody's going to disagree. But ultimately, like math teacher hat, if you follow the order of operations correctly, you're going to get 9. That's it. So all of these are just viral because it is kind of tricky. It's a little tricky there. But the order of operations is important so we can all end up with the same answer. So that's why, but PEMDAS, so PEMDAS for order of operations does work, okay? But what you can do is you could do, there's other ways, there's other like mnemonics that you can do for the order of operations. The one that I like doing is GEMMA, G-E-M-A. Okay. So G stands for grouping, and that's because there's more than just parentheses. So parentheses, right, are just one way. So you could have, are just one way to group things together. So you could have parentheses like this. You could have square brackets like this. You could have curly braces like this. And actually another grouping symbol that you don't often really see like included in these is a fraction bar. So like that one, this one up here, right? If you wanted this to definitely equal 1, the way that I would probably rewrite this would be something like 6 over 2 times 2 plus 1, like that. If I wanted it to be 6 divided by all of that, then I would probably do something like that. Or maybe I would add in some brackets here, because then I would have to work like 2 plus 1 times 2, and then it would be 6 divided by 6, and that would give me 1. So again, there's ways that you can play around with this that make it clearer, like what you actually want somebody to do. But as it's written, poorly written. So E, just like PEMDAS, is exponents. M is going to be multiplicative operations, which is multiply or divide, multiply and divide, left to right. And A would be additive, so that would be add or subtract, right? Some people will say it as gems, so like, but I prefer the gemma because this being like additive, I like that a little bit better. Yeah, so gemma is something that when I started, I teach high school now, so I don't often introduce the order of operations. And PEMDAS is so ubiquitous. It's everywhere in every classroom, in every textbook. Everybody learns PEMDAS. But again, I don't really love it unless you can write it. Sometimes people will write it sort of like P, E, MD, AS. If you read it like that, that's a little bit easier, but yeah, gemma is the one that I prefer, and that's what I stick with. So you want to make sure that your intention is very clear when you're doing order of operations, right? Now, order of operations is just sort of like a hop, skip, and a jump right into solving equations. Okay? Because what you can do is you can also have like, you can change it into like, what's the missing number? If this all equals this, like throw in a variable, those types of things. Okay, let's see. So if we had one like, so if we had a problem like this, 7 plus 10 divided by 2 over 2. And this is a division symbol. This is not a minus. Okay, so what would this one be? So we've got 7 plus 10 divided by 2 over 2. Yeah, so X, exactly. So order of operations, it's not a mathematical property, but it is sort of a standardized way of evaluating these expressions, mainly so everybody knows what you're talking about. Everybody should be getting the same answer, the same evaluation. But again, it's a terribly written problem. I'm with you. But that's why they go viral, right? Okay, so we've got somebody on there saying that it's 6. We got another one, 6. Let's see. Ooh, another math word. So that actually with Gemma, that gives me one of my favorite math words, which is multiplicative. I love that math word. I think it's so many like little consonants, and like that staccato, right? Multiplicative, like, oh, I love it. I love saying that. All right, so this one is not a poorly written expression, right? It's very clear we should all be getting the same answer, right? So we don't have any grouping symbols other than the fraction bar, right? So this fraction bar means that what we need to do first is up here. So the last thing that we are going to do is divide by 2. Okay, so the first thing I'm going to do within here, so this, once I get this sort of like in my group, I need to then follow my order of operations. So the first thing I'm going to do is 10 divided by 2, which is 5. So I've got 7 plus 5, which is 12. So 12 over 2. So 12 divided by 2. Ooh, that is hard to read. So 12 divided by 2, which is going to give us 6. Okay, so this one right here is 6. Okay. Thank you, Alyssa. I love math. And I love being able to share math with everybody. Okay, because it is fun, even though most of us are on a summer break, or maybe you're in year-round school, maybe you have a longer calendar, things like that. But it's still fun. It's still fun to do, and it's still things that kind of pop up. So if you are new to these lives and new to this channel and everything, welcome. So I'm Sarah. I'm a math teacher. I've been a high school and middle school math teacher and science for over 20 years. And so I come in here on Thursdays. Every Thursday I go live, and I will answer any math or science questions you may have. The science questions are a little bit trickier to do unless it's like balancing a chemical equation or something. But usually we tend to stick with like pre-algebra through like algebra 2 level, a little bit into pre-calc. So if you're working on a summer project, or you're taking a class, or you're just curious about something, pop it in the chat and I will do my best to work through it with you. We have lots of things going on. We've got some summer boot camps and all sorts of things going on, okay? So any questions that you have, just put them into the chat. Anything that you wanna talk about or anything like that. Stops. Does that say stops or slope? I can't tell. Oh, slopes. Okay, it looks like stops from here. Okay, so the slope of a line. All right, that is definitely something that comes up a lot, and it's pretty important even when you're in a class like, that's not necessarily math or algebra 1 or anything like that. What was this from? Oh, this was from, I was helping somebody get ready for a biology test. Okay. I'm talking about blood types. Okay, so the slope of a line is the steepness of that line. Okay, so whenever we look at a line, and we've got our coordinate plane here, okay, and we've got a line that passes through these points. Okay, so we've got the slope of the line here. So this is a pretty, I don't know, I would call it pretty average slope. I don't know what an average slope would be, but it looks pretty close to be like a 45-degree angle. Okay, so I would say that's neither steep nor really shallow. But if we were comparing this to another line that passed through that same point, it was going like that. Okay, that is not a very steep slope, right? And if we looked at a third line that was going through the same point, that's a pretty steep slope, right? So all three of these lines are passing through that one point on the line, but their slopes are different, right? So they're changing their kind of degrees, or the steepness. Okay. Now, when we are talking about slope is the relationship between horizontal and vertical. So you can think of this as like a ramp when you have a staircase and you put a board on top of that staircase. Okay, it's the same sort of idea. Okay, so if I'm going from here, I'm going from this point to this point here. Okay, so I'm going to erase this line here. So now what I can do is I can talk about, all right, so in this horizontal distance, I traveled this vertical distance. And if you think about hiking or walking up a hill or anything like that, and you think about like how far forward am I going for every time that I go up, right? When you're looking at different hikes to go on, maybe this summer you're going to go out and do some hiking. You're going to look at the length of the trail, the distance of the trail. That would be like the horizontal distance. But then you've also got to think about the altitude change. I mean, here in Southeast Michigan, there's not a lot of altitude change. But when we lived on the West Coast, there was usually a lot, you had to take into account the altitude change. So if the trail was 2 miles long and the altitude gain was 100 meters, that's not much, right? 100 meters is, 300-ish feet, 400-ish feet, right? It's not going to be terribly taxing necessarily. But if that same 2 distance mile was also giving you 5,000 feet of elevation change, or 5,000 meters of elevation change, that's going to be intense, right? That's going to be really, really intense. That's going to be a really steep hike. So even without seeing any pictures, but just knowing the distance and the vertical, like the elevation change, that's going to give you a good idea of how strenuous that trail is going to be. Okay. So again, slope is that relationship between the horizontal distance and the vertical distance. So the horizontal distance is how much is your X value changing. Okay. So your X value is the horizontal and your Y value is the vertical. Okay. So in this case, between these 2 lines, right, I'm going to look at, okay, so the same vertical change happens here over this long horizontal distance for this first line, but it happens over this little bit of a distance in this second line. So this line is much steeper because the relationship between the vertical distance and the horizontal distance is very different. Okay, there's a much there. Well, it's the same vertical change, right? But it's the horizontal distance is much, much, much smaller. Okay, so when we look at this, so slope is that relationship between the horizontal and the vertical distance. Okay, so slope again is like steepness. So the slope is the vertical change. Forgot the C there. Vertical change over the horizontal change. So we get the vertical change over the horizontal change. So again, if you've got the same vertical change and it's like a smaller horizontal change, your steepness is going to go up. Okay. AP Calculus. Any tips? There are so many resources online. Here's what I would do is I would actually go on to go onto the College Board website and I would start going through. You can get all the sequences for your classes. The AP classes are there for you to see. And so what I would do is I would go through that and start just double checking and maybe previewing some of the concepts and things like that. Being able to look through them once or twice first before your teacher starts teaching them to you could be really, really helpful. But yeah, the AP Calc, any AP course, the curriculum is not a secret. The curriculum is so standard. And there are so many resources out there for you to use that you can start going through. And there's even an AP pre-calc course now. So even going through that and making sure that you're really solid on those things, that could be really helpful for you getting ready to go into AP Calc too. That would be my biggest advice for that. Okay, so if let's just make up some numbers on these slopes. Okay, so let's say that the vertical change is 5 for both of these. Okay, so if they're both going to go through a vertical change of 5, okay, in slope we use the letter M. So if my slope is 5, okay, so I'm going up 5, and that's only taking a little bit of time. So that's 1. So that means that my slope is 5. But if my slope, if I'm going up 5 and it's taking me 10 units to go out, think about like when you're walking like down to the beach or something like that. If it's not a very steep slope, you might go like 10 steps and then 1 step down, and then 10 steps and then 1 step down, right? So that is going to have a slope of 1/2. So this one here is steeper because you're going that vertical distance over a much shorter horizontal distance. Okay. Ooh, fellow math teacher, got any tips on teaching cross sections? Teaching cross sections like actually of like 3-dimensional like solids, or teaching cross sections like cross sections of students, or teaching across sections? I just want to make sure I answer your question correctly. 3D solids. Okay. Ooh, you know, if you can, what I have found to be really helpful is just either getting some of the 3D solids that you can use that like kind of already come like sliced, right? Or like they're connected by Velcro. But what you can also do is have your students make a 3D shape out of clay or out of Play-Doh or something like that, and then have them cut it, right? Like have them actually cut it, or use a piece of like dental floss or something like that to slice it. And then they're gonna be able to see those cross sections. And then if it gets distorted at all, you know, have them kind of like reshape them. But that to me would be real. I like to do things that are really hands-on like that. So if you can find those 3D shapes, or you could, like if you have access to a 3D printer or something like that, then that is really helpful. Also, my own children had you know, when they were a lot younger and we had like those play kitchen things, they make like they make like plastic vegetables and things like that you could actually like cut, and they were connected with Velcro. And so I remember like when I was teaching, I think 6th grade, and we were talking about cross sections, I brought those in, and so the kids were playing, you know, with like apples and pears and all these kinds of things. And so they were able to see that and be able to visualize it. But a lot of kids are going to have an easy time seeing those 3D, like what they're going to look like. Some kids, it's going to be really, really hard for them. So some kids may want to just keep building them out of clay, which fine. I mean, have a Play-Doh day. That's fun. And have them just kind of building the different cross sections. And you could even do something like, you know, have a couple of different shapes and have them, or like, you know, I guess figures, and have them try to create a 3-dimensional solid that has those 3 different cross sections. That might be a really interesting thing. Like create one solid, like it would have to be a kind of a complex solid, but you could have them do, you know, where it's like, if I cut it one direction, it's a rectangle, and one direction, it's a circle. What shape is it? Well, that's going to be a cylinder, right? So thinking about that, okay, if I cut it like the long way, it's going to be a rectangle. But if I cut it the short way, it's going to be a circle, or, you know, maybe a triangle and a rectangle or something like that, right? Yeah, so Jada, just kind of playing with that and just, you know, giving the students the ability to play with those things. Whatever you can make it to be like playing is much more fun. Got any tips on Algebra 2? Oh, I love Algebra 2. So Algebra 2 is really fun because you have a combination between geometry and algebra. So there's a lot of different things that come about from that. A lot of different applications. The fun thing with Algebra 2 is that you start doing... you're going to spend a lot of time with functions. So functions and solving equations and plotting points and graphing things. My number one piece of advice. Anytime you have a function, okay? Anytime you need to graph a function, it doesn't matter. It does not matter what that function is. It could be quadratic, it could be polynomial, it could be linear, it could be anything. But any function can graph with a table. That's my biggest. Any function can graph with a table. Any function. Okay? So if you make, like back when you first learned how to graph things and you make the little t-chart with the x and the y values, any function, it still works. Now, some of these values, some of that when you get into like exponential equations or exponential functions and rational functions and things like that, those can start to get a little bit tricky because you will have some like non-real numbers, right? There are some that are going to be like, they don't go into, you know, you can't actually plot the point or something like that. But anytime you don't know what a function is going to look like, pick some points, plug them in, see what happens, right? Any function. So if we had something like y equals 3x squared minus 1, right? And you go, and your teacher says graph this, and you go, I have no idea what that's going to look like. But you know what you do know how to do is you know that if x is 0, y is going to be negative 1. You know that. If x is 1, 3 times 1 squared is 3. 3 minus 1 is 2. Y is 2. You know that. Okay? All of these different things, no matter what the equation is, you can always get a good idea and you can at least graph something, right? Now, another little clue is that if it's not linear, actually, I don't want to say an always statement. If it's got an exponent in it, there's going to be some curves. It's going to be curvy. So just keep that in mind. If there's no exponent, it's a straight line. Okay, but if there is an exponent, there's probably going to be some curves. So leave that line sort of curvy and up and down and all of that. But really and truly, like any function, and this goes for like SAT, ACT, anything like that. If you're not sure of what a graph is going to look like, just start putting in some points. Find some solutions, right? That is the big thing for this. Louis, the derivatives. Ugh. So the derivatives you usually don't see until later pre-calc into calculus. So we usually, like on this channel, we stick with kind of like algebra 2 a little bit into like logarithms. So we just kind of dip our toe into pre-calc. Maybe somebody else can jump in. Oof, it's been a long time since I did derivatives. So for algebra 2 or really any math class that you're going to be taking, you can graph it with a table, or you can graph it on your graphing calculator. And your graphing calculator will also give you a table of values for you to be able to graph with. Okay. Okay. All right. So, any other questions? Anything else you guys want to talk about? I'll put up another, let's see. Another little order of operations. Let's see. Oh, yeah. Mathematic Fanatic. I love your name, by the way. This is something that I think that students really struggle with this a lot, where, and realizing that like the rules don't change, right? The rules don't change just because you've got this squared or something like this. Like ultimately, these functions are where you plug in a value and you get something out, right? It's that function machine. And so that's something that I always keep trying to re-emphasize or emphasize with my students as we're learning these things, when we're getting into these crazy like polynomials, and when you get into like logs and exponential functions, it can get a little bit murky, but it's still ultimately the same thing, right? When you've got this function, the line on a graph is always the relationship between x and y values. That's it. That's all it is. And so being able to like, it's almost like they need that permission, right? They need permission to go through and just use a t-chart, make a t-chart, get those values in there, right? Okay, so we've got another. All right, let's see. Oh, this one's very similar to. Okay. Yeah, I don't want to do another order of operations thing. Just all the order of operations, all the order of operations problems are, all these viral math problems, it's just because they're poorly written. That's what it is. Can we? Oh, thanks, Fanatic. IKEA. What is IKEA? And then the table is just my dining room table. Okay, let's see. So can we put any, can we put an value with algebra 2? I'm not sure. I don't understand what you're asking with that. Do you mean any value? Can we put any value? Okay. So, let's get into this. So let's say it's asking you, it meaning it's just like an SAT question or something like that. So you're saying graph f of x equals, let's say 2x cubed plus 2. Okay. And let's say you just you come across this and you're like, I have no idea what that looks like. I have no idea what that means. I've never seen that cube up there. I've never seen an equation or a function that or an equation that looks like this. Okay. First thing to notice, this right here is function notation. Okay. So function notation, the f of x just means y. Okay. This is function notation, so that means that when I'm plugging in x here, what I'm going to get out is 2x cubed plus 2. This is ultimately just the y value. So let's take a look at this. Now remember, what I said was if you have an exponent up there, what's going to happen to the line? It's not just going to be a straight line, right? If there's an exponent there, if there's a power, there's going to be some curves somewhere. Okay? Now if I'm just having to graph this, I'm not even going to use the graphing function on my calculator. Okay, so I'm going to look at this and let's just see how close we get. So I'm going to go, okay, well, I don't know what this is going to look like, but I do know that I do know how to graph a line, right? I do know how to graph an equation or a function. So I'm just going to start with that. Easiest x value to start with, 0. Easiest. Okay, so then so if x is 0, I'm going to go 2 times 0 cubed, which is still 0. So 2 times 0 is 0, plus 2 is 2. Okay, so I've got a point at 0, 2. Let's keep it easy, right? Let's go with 1. So if x is 1, I've got 2 times 1 cubed, which is 1, plus 2, which is 4. Okay. So 2, now these are going to get pretty big, right? So 2 cubed is 8 times 2 is 16 plus 2 is 18. So that's getting a little bit big. So I kind of go, ugh, you know what? I'm not going to be able to graph that high because it's getting up to 18. So now let's go the other way from 0. Now I could also choose any fraction. I could choose 1/2, right? I could do however we want to do this, right? So I could do -1. Okay. Can we do it backwards? Because my teacher taught me to do it backwards. Do you mean where you pick the value for y and then solve for what x is? I mean, sure, you could do that, but I mean, plugging in, I feel like, you absolutely can. You can, of course you can. But I find it a little bit easier when I don't know what I'm going for, right? I find it a little bit easier to just pick a value for x and then I just plug it in and, you know, solve for the y. Okay, so -1 cubed is going to be -1 times -1 times -1, which is -1. So 2 times -1 is -2 plus 2 is 0. Okay, so how about -2? So I've got -2 cubed, which is going to be -8. -8 times 2 is -16 plus 2 is -14. Okay. Now, if I wanted to, I could also go through and do some fractions, right? But I don't have to. Because now this is giving me a pretty good idea. I've got some points here that I can actually plot. Okay, so 0 and 2, which is here. 1 and 4, which is here, and then 2 and 18, which is 2, 4, 6, 8. It's way up here. Okay. So then I've got -1 and 0, and then I've got -2 and -14. 2, 4, 6, 8, 10. So it's way down here. Now, here's the part that gets a little bit weird, is that remember, you've got these things here. You've got this exponent, so it's going to be a curved line. So since this goes from 0 down to -14, I know it's going to be way down here, and then it's going to come up, and then it's going to kind of curve. I'm not going to draw a straight line. I'm not even going to use my straight edge, because then this goes up here, and I know this one goes way up to 18. Okay. So as long as I know it's not a straight line, because otherwise, I mean, that definitely looks like it could be a perfectly straight line, right? But I know it's going to be curved, and I know these points are way off the scale here. So that's pretty close. I think that right there is probably going to be pretty close to what I've got. And I know it's hard for you guys to see. It's really hard to see on this. But if I've got 2x to the third plus 2, and I do my graph, yep, it's about, kind of goes, okay, we've got a little bit of a, yep, 0, 2. Hey, the curve is a little bit steeper kind of at the turns, but you know, this honestly is close enough. I'm gonna see it. Now I could have done some little fractions, right? If I did 1/2, I may have gotten a little bit more detail within there, but generally speaking, the graph is the graph. So there I've done my function. Okay, so again, it's going back to that fact that like you can graph any function no matter what it's going to look like, as long as you know that you can just pick some values for x and plug them in. Yeah. Okay, joshing, let's see. I'm wondering how many students enjoy learning from TikTok Live compared to their normal classroom. So, you know, my goal with doing these TikTok Lives is not to like replace what's being done in the classroom, but it's to support. So a lot of times, and this is purely like, I mean, probably more like anecdotal evidence, right? But a lot of students, I think this is a nice space where they can come in and they can ask me to go over a specific problem that they did in the classroom, or, my teacher said something about this in class today and I just really don't know what she's talking about or what he was talking about, right? So this is a really good opportunity for them to just supplement and ask for like clarifying questions. And what I also do is like virtual tutoring. I do a lot of in-person tutoring, things like that. So this is more of like a supplement and a support. It's not meant to like obviously replace what's going on in the classroom. But again, anecdotally, there's been a lot of really good feedback from students just kind of going like, yeah, I think that is that it's a little bit more like, I'm pretty good at explaining things in a succinct way, which usually is it kind of gets to the meat of the problem, and it gets to the piece that they're really struggling on. And so just hearing it may be the exact same thing that their teacher was saying or teaching, but hearing it in a different voice sometimes is all you really need. That's why I always have my students explain stuff to each other. Like, okay, now turn to your partner, turn to your neighbor and explain what I just said. And, when they're working together, sometimes it just takes to be in a different voice and just a different example or something like that for it to be clearer. Yeah. And I think the anonymity on TikTok and, other platforms and things is really nice, for students to be able to ask me to go through things, because, there may be a high school student, I don't know if you were in here before when we were talking about slope, but there may be a student who's like a junior in algebra 2 or something, and they're not really sure about what slope actually is. And so they can ask here and I'm going to go over it. There is zero judgment, right? And in these, certainly during the school year is obviously more a broader audience, but we'll have a lot of students in there asking questions about like calculus concepts and things like that, and we'll have other people jumping in that it may be something that I'm not, that I didn't see, or usually the chat is just like going nonstop, so I try to pick up and answer as much as I can. But there's a really good community here where people will jump in and help and try to answer the questions too, and it's very judgment free and supportive, I think. But yeah, I think it's a little bit of both. Being able to sort of be anonymous, and it doesn't really matter what grade you're in or what class you're in or what your teachers are going to think or what your friends are going to think, right? Because I know that I've got students who don't, as hard as I work to make a welcoming, inclusive, and supportive and safe classroom environment, I know that there are still students who struggle to ask those questions in class. Whether it, and I'm hoping that it's not judgment from me that they're afraid of. I'm hoping that it's something else that's going on. Maybe they're worried about what their peers are going to think and things like that. But my classroom is, I always tell my students I hate silent math classes. I hate them. It shouldn't be silent. Unless you're taking a test, obviously. But when you're doing discussions and learning things, like learning should be loud. Learning should be kind of messy. So yeah. All right. So let's see. We got time for one more concept. What do we want to do? Let me know. What should we do? Should we do another graphing a function? Should we do another terribly written order of operations problem? Should we solve a polynomial equation? What should we do? You guys let me know. One of my favorite things to see is like the different ways of that people do like multiplication and division, and you know, you've got the repeated you see like the repeated subtraction, repeated addition, all of that. Those are really cool. I think those are really neat ways of doing that. Right? Okay, let's see. Okay, how about, let's do a solving a polynomial, because everybody loves solving polynomials. Okay. I'm just going to make one up. I have no idea what it's going to be. Let's do 2x squared plus 3x equals 10 plus x. Now let's leave it as a simplified radical. I don't want to round it. We'll just solve this the way. So this is what we call a quadratic or a polynomial equation. So it is a polynomial equation because there are many terms, but it is also more specifically a quadratic because the highest power is 2. Okay, so we see this x squared. Now this is something, if you're in Algebra 2, you're going to see so many of these. This is what we spend a lot of time in Algebra 2 learning, is how to solve these polynomials and how to solve these quadratic equations and things like that. So when we're solving this, the very first thing we need to do is we need to get everything over on one side. We need to get it. We need at least all of the x's on one side. So the first thing I'm going to do is subtract the x from both sides. Okay, so this one goes away. So now I'm left with 2x squared plus 2x equals 10. Okay. Now what I have here is I have choices now. Okay, so I could divide everything by 2. In fact, that's what I'm going to do, because I've got 2, 2, and 10. I'm going to go ahead and I'm going to divide everything on both sides by 2. So that gives me x squared plus x equals 5. Okay. Now here, I'm getting into a little bit more of my choices, right? But with this one, since this is a 1, since its leading coefficient is a 1, and this is a 1, and this is a 5, I'm going to go ahead and I'm going to solve this. I want to write it as equal to 0. So I'm going to rewrite this. Ultimately, the ultimate quadratic equation that I'm going to be solving is this one. It's x squared plus x minus 5 equals 0. Now, this is equivalent to what I started with up at the top, right? It's equivalent to up here because everything that we did was balanced. It followed the properties, all of that good stuff. So this right here, 2x squared plus 3x equals 10 plus x, is the same thing as x squared plus x minus 5 equals 0. Same exact thing. So now with this, I'm going to check to see if it's factorable. So if it's factorable, I could just solve it by factoring, and that's nice and clean. But the only factors of negative 5 are 5 and negative 1, or negative 5 and positive 1, and those don't add to 1. So my only other option is quadratic formula. So quadratic formula is our favorite little ditty. Okay. We have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So these a's, b's, and c's, they all have to do with these coefficients. So a is 1, b is 1, c is negative 5. So I'm going to plug in all of those values. Okay, so my values for it. So I've got x equals negative b, which is negative 1, plus or minus, oh my God, the square root of b squared minus 4 times a times c all over 2a, which is 2 times 1. Okay. Now you can't really just plug this all straight into your calculator. We don't want to do that anyway. So this part under here, underneath the square root symbol, this is called the discriminant. Okay, that's what we're going to figure out first. I'm also going to make this into a 2. So I've got x equals negative 1 plus or minus square root. So 1 squared is 1 minus 4 times 1 times negative 5. So this ends up being 21 over 2. 21, I'm sorry, square root of 21 can't be simplified because it doesn't have any perfect squares as factors. It really just has 7 and 3, and those aren't perfect squares. So as weird as it feels, this is my answer. This is it. So I'm going to leave this. Oh, hold on, guys. I got to do the little puzzle piece thing. So I am going to leave this just like this. That's going to be my solution. So my solution would be negative 1 plus or minus square root of 21 over 2. So that means that I do have 2 solutions. There's going to be 2 zeros. That's that plus and minus. If your teacher asks you to round them to the nearest 10th, you can do that, but you also don't have to. This is the more exact version. It's kind of like instead of writing like 0.3, I'm going to write 1/3, right? 1/3 is not the same thing as 0.3 unless you round it, right? But even that, it's not the same thing. It's the rounded version. Okay. All right. So we have been on for just about an hour. Let's see, with real analysis, I don't think that's something that I could really help with. I'm not sure what you're looking for with that, but we will be back next week. Let's see. Oh, 7th grade. Going into 7th grade. So here are the things that I would recommend. Okay, going into 7th grade math, order of operations, integers, okay, like add, subtract, multiply, divide, integers, fractions, and graphing. Those are the big things for going into 7th grade math. Okay. And if you're feeling a little nervous about that, you can also send me a DM, send me a message, because we could probably work out some one-on-one tutoring or something like that. All right, guys. Have a wonderful evening. Enjoy your summer. Keep doing math every day. It's out there. All right. Goodbye.